Hello, this is Satbir Malli. The topic of our discussion in this video tutorial is finding integrating factor of differential equation. In the previous video, we have learned what is integrating factor and why they are useful. In this video tutorial, we will discuss a particular situation where we can find the integrating factor of a non-exact differential equation. And in this case, we assume that if the integrating factor only depend on x and y, then we can compute using these two formulae. Or in other word, we will compute this quotient, and if this quotient is only depend on x, then our formula for finding the integrating factor is this. And if this quotient is only depend on y, then to finding the integrating factor of this differential equation, this type of quotient is this. And to notice, these are two different quotient, so it's not the same. So we have to compute the two quotient and then decide that which formula to use. Let's try this formula on this practical example. So I have a differential equation which is already written in mdx plus nd form. So first I will select what is my m. So this is my m and this is yn. I'm going to use the easy notation to calculate the partial derivative. So partial derivative of m with respect to y. So this is the easier notation. It's going to be a 3. I'm taking the partial derivative with respect to y. So x is a constant. And therefore this is a 3x minus 2y, and the partial derivative of n with respect to x, if I FOIL this and take the derivative, is going to be a 2x minus y. And clearly the partial derivative of m is not equal to the partial derivative with respect to x. So this is a non-exact differential equation. It's really important to check the exactness first, because if the differential equation is already exact, we do not need to find the integrating factor. We can use a technique which we learned in our previous video to solve those type of differential equation. Okay, if now the differential equation is not exact, and we will try to find the integrating factor. And first we assume, what if the integrating factor is only depend on x or y? So if this is the case, I'm going to compute these two terms, m with respect to y minus n with respect to x. This is a divide by n. And I'm going to also compute n with respect to x minus m with respect to y. I'm going to divide this by m. And let's see which one is only depend on x and y. So if I calculate my minus nx, it is a 3x minus 2y, and then there is a negative sign here, and this is a 2x minus y, and whole entire thing is a divide by n, which is x minus y. And then I will basically compute this. So this is going to be x minus y on the top, and then they have x minus y. So this turned out to be, this only depend on x. So this factor is only depending on x. I will compute the second one as well. So clearly it's going to be 2x minus y minus 3x minus 2y divided by 3x minus 2, no sorry, it's divided by m, which is 3x y minus y square, and therefore this is equal to y minus x, whole thing is divided by 3 xy minus y square. So this cannot be written as a function of y. So this is clearly is not a function of y. So it means we will use this one because it's a function of x. So what our formula for the integrating factor is, because the integrating factor is only depend on x now. So simply the formula is we will integrate e to the power that function 1 over x dx, and therefore this will be e to the power natural log of x, and then this is just simply x. And also you can verify that whether this is integrating factor or not by multiplying the differential equation by this factor. So if I multiply this, it's going to be a 3x square y minus x y square dx, and plus it's going to be x cube minus x square y, I'm just simplifying a little bit, is equal to 0. Now if I compute the partial derivatives with respect to x and y, so the derivative with respect to y is 3x square minus 2xy, and the partial derivative with respect to x is 3x square minus 2xy. So clearly these are equal. So this differential equation, the new differential equation, is exact. It means this was the correct integrating factor which we compute using this formula. Okay, here I have one quiz problem for you to practice. Please pause the video for 1 and 2 minutes and work on this problem. I have one more practice problem for us to practice. So let's calculate the integrating factor of this differential equation as well. So this is my m and this is my n. So if I calculate the partial derivative of m with respect to y, it will be, because this is going to be a now product rule, so it's going to be a sine y plus x plus y, the derivative of sine is cosine y, and the derivative of n with respect to x is sine y. So clearly the partial derivative of m with respect to y is not partial derivative of n with respect to x. So it is not a exact differential equation. Now we will try to find the integrating factor, and we only can find it integrating factor by using this method if they only depend on x and only depend on y. If they do not depend on x and y, we cannot use this method to find the integrating factor. We may have to look for a different method in that situation. So let's calculate my minus nx divided by n, or the second term is nx minus my. So you just flip the top term and then divide by m. So if I subtract sine y plus x plus y cosine y minus sine y, whole entire thing is divide by n, which is equal to x sine y plus cosine y. Now this term cancel out, so you have left with x plus y and then just cosine y on the top. However, in the bottom you have sine xy plus cosine y. So I don't think this can be written as a function of y or x alone. So we will leave them alone right now and compute the second term meanwhile. So the top is going to be same except with the negative sign. So x plus y cosine y, because the term flip on the top, and you divide by, instead of n, now you divide by m. So x plus y, and then you divide by basically sine y. As you can see, this cancel out and then you get minus cosine y divided by sine y, which is a cot of x. Now, since this is a function of y only, we can use the integrating factor method, which is a e to the power integration of minus cosine of y divided by sine of y dy. And in order to compute this, you can use the u sub, basically, or you can use this was the formula of cot of x. Here I will use the u substitution. If I take my u is equal to sine of y, my du is equal to cosine of y. So it's basically 1 over u du. And that give you e to the power minus ln of u, or in other word, 1 over u. And what is u? U is a sine of y. So therefore, your integrating factor in this situation, mu of y, is 1 over sine of y, which you can verify by multiplying the differential equation both sides, or the throughout the differential equation 1 over sine y, and then you can check the partial derivative of the first term with respect to y and the term which is attached to dy with respect to x, whether they are equal or not. So, okay, this is the end of this video tutorial. Thank you very much for watching. I will see you in the next video. Bye for now.